Hello everyone. Today we are going to solve the lead code problem valid word square. We are given an array of strings, words, and we need to return a true if it forms a valid word square. A word square means that reading the words row-wise is exactly the same as reading it column-wise. For example, if the first row has the word A, B, C, D, then the first column will have exactly the same characters A, B, C, D. And the same for the second row, if it is P, N, R, T, then the second column will also be exactly the same P, N, R, T. And so on and so forth for the list of the words in the list. The idea is very simple. For every character at position I and j in the word list, we must make sure that it is equal to the character at position j and I. For example, if I and j equals index 0 and 3, and in this case they map to the character C here, then the indices j and I will be 3 and 0 should also map to the character C at that position. So 0 and 3 will be that character, and 3 and 0 will be that character, and they are the same. And we should do that for every character in the array list. Now let's move to the implementation. It is very easy. We will loop on each word in the words list. And then we will loop over each character in this word, each word. Then we will compare each character at positions I and j, and if it's not equal to the character at position j and I, we will immediately return false. And at the end, if these two for loops pass, that means that we have a word square. So we will return true. But be careful to the edge cases. For example, we may have a word list like A, P, C, and the second word is just P. So if we applied our algorithm on these two words, so at index 0 and 0, if I and j equal 0 and 0, in both cases, it will return the character A. If the indices are 0, for the next indices 0 and 1, and 1 and 0, it will return P. But for the third case at index 0 and 2, for the first word we have C, but we don't have that index in the second word, and this will lead to an error. So we have to make sure that we don't exceed the bounds of each word. To do so, I have to add an extra condition to make sure that the index j is not exceeding the word size, and if so, it will return false. And this is the final code. Let's run it to make sure it doesn't have any errors. And here we go. Let's submit it. Yes. And the space complexity in this case it will be constant, and the time complexity will be O of n multiplied by s, where n is the number of words in the list and s is the maximum length of each word in that list. Hope you liked this video. If you like it, please like and subscribe, and waiting to see you all in next video. Bye.